Dear students, welcome to the presentation of Session 2, Unit 1, IC Logic Families for the third semester Electrical and Electronics Engineering students for the subject Digital Electronics. The course outcome remains same for the unit number 1, that is understand the basics of IC Logic Families. So once the unit 1 completes, the student should be able to understand the basics of IC logic families. So what is IC? What are the different families of IC? And what are the different families? The comparison of the families. So these are all you can able to understand and answer the questions. So that is the basic idea of the course outcome. Next, we'll move on to the next slide. So in the session 1, so already we have learnt about some of the characteristics of the IC logic family. So in this session, we will discuss some more characteristics of the IC logic family. So we'll see what are all the remaining characteristics of the IC logic families one by one. The first definition in the session 2, noise margin. So the noise margin, the definition goes like this: the maximum noise voltage level that is tolerated by a gate is called the noise margin. So it is the maximum noise voltage level that is tolerated by a gate, that is called the margin. So once the noise level crosses this voltage level, so then your output will not be the desirable one. Okay, so your output will be undesirable one. So up to some certain limit of the noise, so it can able to handle. Okay, so that margin, it is called the noise margin. So noise is basically a distorted sine wave. Okay, so the sine wave will not be proper, so there will be distortion in the sine wave. So the noise may be due to so many reasons, maybe the connecting wires or maybe some interference. So many reasons are there. Okay, so this noise voltage level induced in the circuit, so should not cross some limit. Okay, so that limit, that we will call it as a margin. So once that crosses that margin, so your output will be not desirable one. So ನಮಗೆ ಬೇಕಾಗಿರುವಂತ output ಅಲ್ಲಿ ಬರೋದಿಲ್ಲ. So that is the noise margin definition. So next we'll move on to the next definition, fan in. Okay, the fan in, it is the number of inputs a logic gate can handle. Okay, so logic gate can have single input, 2 input, 3 input, or more than 3 inputs. The fan in basically refers to the how many inputs a particular gate can handle. So in data sheets, so they will mention the fan in so and so. Okay, so by seeing the data sheet, we can able to understand that the particular gate can handle how many number of fan in they are given in the data sheet. So that is called the fan in. So it is a number of inputs a logic gate can handle. Okay, so more than the inputs if you give the particular gate, then your gate won't be work properly. So that is the idea. So for instance, the fan in for the AND gate shown in figure below is 3. So just you can observe here. So this is one AND gate. Okay, so these are the 3 inputs and 1 output. So fan in for this AND gate is 3, meaning so we're having 3 inputs, 1, 2, 3. So that's why the fan in for this AND gate, we can calculate it as 3. By just saying that, we can able to calculate the fan in for this particular gate. Okay, so this is the fan in concept. So wherever you just see the fan in, then you should come to your mind that it can handle that many number of inputs. So that is the basic funda. So next we'll move on to the next definition, fan out. Okay, so last slide we have seen the fan in, that is the input side, and now we are seeing the fan out, that is the output side. The fan out of a logic gate is the number of gates that can be reliably driven by a gate. Okay, So again, I will read the definition. The fan out of a logic gate is the number of gates that can be reliably driven by a gate. Okay, so meaning, so just you can observe here, this is a two input NAND gate. The output of the NAND gate is again driven to the input to some other gate. Okay, so just observe here. So this is the two input NAND gate. The output is given to this NAND gate, and next the same output is given to this NAND gate, and the same output is given to the third NAND gate. Okay, so here we are driving this output to this input of these three NAND gates. So that is the fan out. So is the number of gates that can be reliably driven by a gate. Okay, so this is the gate, this is driven by this three gates. Okay, that is called the fan out. Okay, that is the output side of a particular gate which can able to drive some other gates. So that is the fan out number will gives how many that gates it has to drive. So that will give the number of the fan out. Okay, so that's the concept of fan out. So now next definition, operating temperature. So temperature is one of the basic environmental factor, so which affects the function of ICs. So ICs, it's not the matter of ICs. So for any electronic items or for any scientific things, the temperature is the main factor which affects the operation of any instruments. Okay. So here also the operating temperature of the IC is that it is the temperature at which the IC ensures normal operation. Okay. One range, the operating range is that IC ensures normal operations. Okay. So ಈ temperature range ಒಳಗಡೆ ಇತ್ತು ಅಂದ್ರೆ then IC will ensures normal operation. So abnormal behavior ಅದರಲ್ಲಿ ಬರೋದಿಲ್ಲ. So normal ನಮಗೆ ಏನು ಬೇಕೋ desirable function ಗೆ ನಾವೇನು ಡಿಸೈನ್ ಮಾಡಿರ್ತೀವಿ ಐಸಿನ, so that particular function it will do if it is lies in the within the certain range. Okay, so that range we'll call it as a operating temperature. So operating temperature in the ಆಚೆ ಆದರೂ plus or minus ಈಚೆ ಹೋದರೂ ಕೂಡ that IC will not work as per the design. Okay, so that is the main concept. So just we can see here, the range specified for commercial application is 0 degree centigrade to 70 degree centigrade. So this is the operating temperature for the ICs used in the commercial applications. Okay. So commercial applications, you can see many appliances. So many things. Okay. So there from 0 degree to 70 degree centigrade, so they will operate comfortably. Similarly, for industrial, it is 0 degree centigrade to 80 degree centigrade. So just observe here. So here it is 70 degree, and for the industrial it is 80 degree. So industrial applications, so it may be exposed to heat environment may be there. So that's why it is extended up to 80 degree centigrade. And this is another important factor for military applications. It is minus 55 degree centigrade to plus 125 degree centigrade. So because the military applications, so there may be a extreme conditions. So extreme cold condition will be there. So there also some of the instrument needs to be worked. So in that case, it will be minus 55 degree centigrade. So IC has to work at the temperature of minus 55 degree centigrade. And the positive extreme, that is plus 125 degree centigrades in the deserts places or in so many other places. Okay, the temperature may be more, or some in the heating environment places. So that is plus 125 degrees centigrades. So there's a wide range given for the military applications because it is a critical one. So that's why in the military applications, it is the range is minus 55 degrees centigrade to plus 125 degrees centigrade. So this is the operating temperature for military applications. Okay, so this is about the operating temperature of the IC. Okay, so in this, this is the temperature at which the IC ensures normal operations. Okay, so if it exceeds, if it comes out of this range, then your IC will not work properly or as per the desirable function. Okay, so that is the operating temperature. So next we'll move on to the Next slide, logic voltage level. Okay, it is a specific voltage or a state in which a signal can exist. Okay, so it is a specific voltage or state in which a signal can exist. ಒಂದು ಸಿಗ್ನಲ್ ಅಂತ ತಗೊಂಡಾಗ ನಾವು ಸೊ ಅದು ಯಾವ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇದೆ ಅಥವಾ ಯಾವ್ದು ವೋಲ್ಟೇಜ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ಇದೆ, ಸೊ ಅದನ್ನ ಲಾಜಿಕ್ ವೋಲ್ಟೇಜ್ ಲೆವೆಲ್ ಅಂತ ಕರೀತೀವಿ. ಓಕೆ, the two states in the logic voltage level are high or low. So ಇಲ್ಲಿ ನಮಗೆ ಡಿಜಿಟಲ್ ಅಲ್ಲಿ, as I already explained, there may be only two states, high ಇರಬಹುದು ಅಥವಾ ಲೋ ಇರಬಹುದು, 1 ಇರಬಹುದು ಅಥವಾ 0 ಇರಬಹುದು. ಸೊ ಸಿಮಿಲರ್ಲಿ ಲಾಜಿಕ್ ವೋಲ್ಟೇಜ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ಕೂಡ ಎರಡು ಸ್ಟೆಪ್ಸ್ ನಮಗೆ ಸಿಗುತ್ತೆ, ಹೈ ಇರಬಹುದು ಅಥವಾ ಲೋ ಇರಬಹುದು. ಸೊ ಈಗ if you observe this figure, so this is the 0 volts, this is a low state, and this is a plus 5 volts, it is a high state. Okay, so plus 5 volt or high state or logic 1. Okay, similarly if you come here, it is 0, so logic 0 ಅಥವಾ low ಅಂತ ಕರೀತೀವಿ ನಾವು. So this is high state and this is a low state. So pulse, it is starting from 0 to high, again it stands high for some time and then it is falls to low sides, and from this side it is low for some time and then it will rise for the up for the high state. So these are the two logic levels, plus 5 volts, okay, that is high, and 0, it is the low voltage level. So this is the signal can exist. Okay, so you can just observe here, so there is one resistor connected to a switch and that is connected to a ground. The resistor is connected to the plus 5 volt VCC, that supply is given as plus 5 volts. Okay, so when this resistor is not connected to ground, so then it is treated as high voltage, that is high state. Okay, that is plus 5 volts, because this plus 5 volts from the VCC, that is directly accessible. So that's why in this condition, so we'll get this pulse, plus 5 volt pulse. In this figure, if you just observe here, we are closing the switch. So once the switch is closed, okay, so now it is grounded. So it is grounded and it is comes to 0. So it is 0. Now switch is open, plus 5 volts. The switch is closed, it is 0 volts. So these are the two states, logic voltage level. Plus 5 volts and the switch is open, it takes from the supply. When the switch is closed, it is grounded, so it will become 0. So these are the two logic voltage levels. Next, we'll move on to the next definition, positive logic. So already in the last slide, we have seen the two logic voltage levels we have seen. So now we see the positive logic. So what do you mean by positive logic? The logic value 1 is considered to be more positive voltage level, plus 5 volts. So logic value 1 anta enta bantu andre, that is will be the more positive voltage level, that is we'll consider it as plus 5 volts. So plus 5 volts, that is called as logic value 1. That may be also called as true or on. Okay, so both all these are same. So logic value 1, that may be also called as true or on, or it is considered to be more positive voltage level, plus 5 volts. That is called the positive logic. Okay, next, the logic value 0 is also called as false or off state. Okay, it is assigned to the less positive voltage level, that is 0 volts of the digital circuits. So see here, this is the low state and this is the high state. This is the leading gauge and this is the trailing gauge or falling gauge. So this plus 5 volts, we can call it as logic value 1 or true or on. Okay, so all these things are same. So similarly, for the logic value 0 means it will be false. This is false or off condition. So this is on condition and this is the off condition. So if we take a pulse, so this is low state, this is high state, This is the leading edge, this is the trailing edge, or we can call it as falling edge, rising edge and falling edge. This is called the positive logic. Similarly, comes to the next definition, negative logic. So, in the previous slide, we have seen the positive logic. Here it is a negative logic. So that is a mirror image of positive logic. Okay. The logic value 1, also called true or on, is considered to be less positive voltage level. So now here it is reverse of the positive logic. So in the last slide we have seen the logic value 1 refers to the plus 5 volts. Okay. So but here the logic value 1 refers to the 0. So ಇಲ್ಲಿ ನಾವು negative logically logic value 1 ಅಂತಂದ್ರೆ that will be 0 volts ಅಂತ ಅರ್ಥ. ಗೊತ್ತಾಯ್ತಾ? Next, the logic value 0 is also called as false or off is assigned to more positive voltage or plus 5 volts. So ಇಲ್ಲಿ ನಮಗೆ logic value 0 ಅಂತಂದ್ರೆ ಹೈ ಇರುತ್ತೆ, plus 5 volts ಗೆ ನಾವು 0 ಅಂತ ಕರಿತೀವಿ. So exact reverse of positive logic. Positive logically ಏನಿರುತ್ತೆ ಅದರದ್ದು ರಿವರ್ಸ್ ನಮಗೆ ನೆಗೆಟಿವ್ ಲಾಜಿಕಲ್ಲಿ ಸಿಗುತ್ತೆ. ಸೊ ನೆಗೆಟಿವ್ ಲಾಜಿಕಲ್ಲಿ 1 ಅಂತ ಕೂಡಲೇ ಇಟ್ ವಿಲ್ ಬಿ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ 0 volts. So logic value 0 ಅಂತ ಕೂಡಲೇ ವಿಲ್ ಕನ್ಸಿಡರ್ ಇಟ್ ಆಸ್ plus 5 volts. So these are the difference between logic value 1, logic value 0 in positive and negative logic. So next definition, speed. Okay, speed is the time taken by the gate to change its output. So speed is the time taken by the gate to change its output. So once if you apply the input, so you'll get the output. The speed is how much time it has taken for giving the input and getting the output. So some the definition you already seen in the propagation delay. Okay. So there also we have talk about the speed. So if the propagation delay is less, speed will be more. If the propagation delay is more, speed is less. So similarly, the same thing. Speed is the time taken by the gate to change its output. So giving the input and getting the output. So it is usually specified in terms of microseconds. So how many microseconds it has taken to change its output. Okay. So this is the definition of speed. Okay. So these are the definitions or characteristics we have seen for the ICs. So in the session 2, so we have seen just a recap of this. Just we'll just go to the all the definition we have studied. Okay. So noise margin, that is the maximum noise voltage level that is tolerated by a gate. It is called the noise margin. So how much is the gate can able to handle the noise voltage level. So that is called the noise margin. So next, fan-in. So it is the number of inputs which a particular gate can able to handle. So if you give more the inputs, whatever it is specified, then you won't get the desirable output in the gates. Similarly, fan out will refers to the output side. Okay, the output is the number of gates that can be reliably driven by a gate. So that particular gate output is driven to how many other gates, that is given by the fan out. The operating temperature, it is the temperature which the IC ensures normal operations. Okay. So operating temperature ಯಾವ IC ನಲ್ಲಿ ನಮ್ಗೆ ಎಷ್ಟು ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೋ ಅಷ್ಟೇ ಇದರೊಳಗಡೆ ನಾವು ಅದನ್ನು ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಆ ಟೆಂಪರೇಚರ್ ಬಿಟ್ಟು ಯೂಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, that IC will not give the satisfactory performance. Okay. That is called the operating temperature. So for they are classified for commercial application, industrial and military applications for different temperature range for different applications depending on the conditions. So logic voltage level. So the law, it's a specific voltage or a state in which a signal can exist. So signal anta ನಾವು ತಗೊಂಡಾಗ, so ನಾನು ಅನಲಾಗ್ ಅಲ್ಲಿ ಹೇಳಿದೆ that is a continuous signals. ಅಲ್ಲಿ ನಮಗೆ states ಬರೋದಿಲ್ಲ. But in digital ಅಲ್ಲಿ you are having the two states, high ಮತ್ತೆ low. So that's why in this digital, so you can put a logic voltage level. So maybe high or low. So two states we can able to say. So in that we have a positive logic, the logic value 1. If you tell the logic value 1 or true or false, then it is considered or it is taken as plus 5 volts. So logic value 0 or false or off, it is taken to the 0 volts. That are the two things. Similarly, negative logic, it is the reverse of the positive logic. So there 1 is refers to the plus 5 volts. Here in the negative logic, plus 1, logic value 1 refers to the 0 volts. Similarly, logic value 0 refers to the plus 5 volts in the negative logic. So this is the negative logic. Just it is the reverse of positive logic. So high and low state. So high it is 0 and low it is the logic value is 0. It is refers to the plus 5 volts. So this is about the negative logic. Speed, again it is the time taken by the gate to change its output. So how much time it has taken a particular gate to change its output, and it will be measured in microseconds. So these are all the definitions or characteristics of the IC we have studied in the session 2. So here there are some of the multiple choice questions in the session 2 what you have studied already. So question number 1, suppose that the digital IC family has a fan out of 6, it implies that the gate can supply the current to dash of same family. So digital IC the fan out 6 ಅಂತ ಅಂದ್ರೆ ನಮಗೆ ಸೊ ಎಷ್ಟು ಇಟ್ ಇಂಪ್ಲೈಸ್ ದ ಗೇಟ್ ಕ್ಯಾನ್ ಸಪ್ಲೈ ದ ಕರೆಂಟ್ ಟು ಎಷ್ಟಕ್ಕೆ ಇದಕ್ಕೆ ಅದು ಕೊಡಬಹುದು ಅಂತ. ಸೊ ಆಪ್ಷನ್ ಎ 6 ಇನ್ಪುಟ್ಸ್, ಆಪ್ಷನ್ ಬಿ 6 ಔಟ್ಪುಟ್ಸ್, ಆಪ್ಷನ್ ಸಿ 12 nodes, ಆಪ್ಷನ್ ಸಿ 12 nodes, ಆಪ್ಷನ್ ಡಿ 12 branches, which is the right answers. So fan out of 6. So fan out 6 ಅಂದ ತಕ್ಷಣ what you should come to your mind? So it is the output of a particular gate which can able to handle the other gates, because that output we are given it as input to the some other gates. It is the option A, 6 inputs. So 6 fan out 6 ಅಂತಂದ್ರೆ ಆ ಗೇಟ್ ಇಂದ ಬರೋದಕ್ಕೆ ನಾವು 6 ಇನ್ಪುಟ್ಸ್ ಗಳನ್ನ ನಾವು ಆ ಔಟ್ಪುಟ್ ಇಂದ ಡ್ರೈವ್ ಮಾಡಬಹುದು ಅಂತ ಅರ್ಥ. Okay, so the option A is right answer. So second question, from where do the voltage noise get induced into the logic circuit? Okay, so I already explained noise, voltage noise. So adu ಯಾವ ಇದರಿಂದ ಬರಬಹುದು ಅಂತ. So we'll see options. Option A, from a gate output to the load. Option B, from the connecting wires used between the two gates. Option C, both A and B. Option D, none of the above. So noise, voltage, ಚಾನ್ಸಸ್ ಇಂಡ್ಯೂಸ್ಡ್ ಆಗಕ್ಕೆ ಯಾವುದು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ? ಆಪ್ಷನ್ ಎ, ಆಪ್ಷನ್ ಬಿ, ಆಪ್ಷನ್ ಸಿ ಆರ್ ಆಪ್ಷನ್ ಡಿ. ಸೊ ಫ್ರಮ್ ಗೇಟ್ ಔಟ್ಪುಟ್ ಟು ಲೋಡ್, ಫ್ರಮ್ ದ ಕನೆಕ್ಟಿಂಗ್ ವೈರ್ಸ್ ಯೂಸ್ಡ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಗೇಟ್ಸ್, ಅಥವಾ ಎರಡೂನಾ ಅಥವಾ ಯಾವುದು ಇಲ್ವಾ? ವಿಚ್ ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್? ಸೊ ದ ರೈಟ್ ಆನ್ಸರ್ ಇಸ್ ಬೋತ್ ಎ ಅಂಡ್ ಬಿ. ಫ್ರಮ್ ಎ ಗೇಟ್ ಔಟ್ಪುಟ್ ಟು ದಿ ಲೋಡ್ and from the connecting wires used. So these two may cause the voltage noise. This will induce the voltage noise in the circuit. So question number 3, in positive logic representation, bit 1 represents. So bit 1 anta positive logic alli kottaga, so what it will take? Option A, logic high, or option B, logic low. So what is the answer? So positive logic, bit 1. So it should be option A, that is logic high. Fourth question, the operating temperature range of ICs will be in the range of. So ಯಾವ range ಅಲ್ಲಿ ನಮಗೆ operating temperature, so range of the temperature ಇರುತ್ತೆ. So we have seen the 3 different applications of ICs: commercial, industrial and military. So by seeing all the 3 applications, so we have seen the 3 temperature ranges. So option A, minus 40 degree centigrade to plus 150 degree centigrade. Option B, minus 55 degree centigrade to 125 degree centigrade. Option C, minus 20 degree centigrade to 100 degree centigrade. Option D, 80 degree centigrade to 250 degrees centigrade. So the right answer is option B, that is minus 55 degrees centigrade to 125 degree centigrade. So this is the operating temperature of ICs. So because it will covers both in a commercial as well as industrial, it will comes under this range only. Question number 5, speed is specified in terms of what? Option A microseconds, option B millisecond, option C nanoseconds, option D second. So what is the unit of the speed? So speed of the logic circuit. So that will be usually what is the answer? Option A or option B or option C or option D? So that will be option A. So it will be specified in terms of microseconds. Okay, so this is the right answer. So this is about the MCQ. This multiple choice question, few multiple choice questions relating to the session 2 of unit number 1, IC logic families. So these are the references books you can go through. This is the Wikipedia. You can search any information. This is the content development team. Thank you very much for watching this presentation. Thank you.